All right. Welcome back to the Ethereum Protocol Fellowship Study Group. Today we have a special presentation from Mario on how to run a node. Go deep into what the hardware and process of running a node, and then we'll have lots of times for questions after he does a demo of how to get it set up and start running a testnet.
Yeah, thank you so much for the intro, Josh. And welcome everyone to the node running workshop. There is a lot to unwrap here. It's finally the time to put things in practice. It's been a lot of theoretical knowledge, a lot of talk about the protocol architecture or the consensus execution layer, etc., etc. But today, I want to show you how it actually works, how we put it into practice. So, if you remember my very first presentation, I asked you like, what is Ethereum? It's protocol, it's love, it's the future, and now we will become all of that. We will become Ethereum by actually running, by actually using it. So it's pretty exciting. Yeah, I look super pale like the camera. Anyway, I am also watching the questions. Feel free to drop questions in the Discord. Um, there's a dedicated thread to that. However, a part of that, you can follow the workshop. So what I will be doing is figuring it by myself because I do this like maybe more than once a week, but I still forget. There's so many different clients, and I need to remember all the flags and all the niches. So I will be going as I go to install and run Ethereum, and you can follow what I'm doing. You can try it yourself. If you run into any issues that I'm not able to answer during the workshop, we will have time after that. After this is over, we would switch to um, uh, Jitsi for like more interactive session if you wish, if you guys want to share your screen and troubleshoot. So because here only I will be sharing my screen. I was connected with my phone in case that my microphone gives trouble, so we can test that later. First, I will share my screen. Yeah, awesome. So what you're looking at is Debian 12 virtual machine. So let's start with the basics actually. Let's start with going to the workshop outline so I know what I'm supposed to talk about because I outlined it all here. So yeah, let's start with the introduction. So yeah, this is the doc with all of the resources you will need. You can just click to get into all the places from here. But let's start with the the short recap of what we discussed before in the fellowship. I believe you in the study group because I'm sure you folks understand what the node is, what the client is at this point. Just to recap, like why you want to even do this, and it's to use Ethereum, right? So we are going to take the actual implemented spec and all of the behavior that Ethereum is supposed to do, and we're going to execute it ourselves, which means there will be different stages, different operations that a client is doing, and of course it's a client pair. So there's execution and consensus client. Now, why would you want to do this as an individual? Is to uh, be able to actually use Ethereum. If you are using a wallet, if you are developing smart contracts, if you are anyway interacting with Ethereum, checking transactions on Block Explorer, for example, you're always using some third party, the Block Explorer provider, the wallet, RPC provider, etc. You're trusting someone else's node about its view on the current state of the Ethereum. But this way, you can run your own client and just do it in a trustless way because you see exactly, it's a free open software, so you see exactly what is being executed, what is being done, and you can verify chain on your own machine basically. Now, first thing is to choose a client pair. to choose the actual combination of what node we want, what client implementation we want in the weeks before you learn. There is many of them. A good overview is this one with all the different execution clients and consensus clients. Yeah, and also tips on running them. We might be using this later because it's full of great tips and explains basically the whole process, and also some simple minimal commands for each client. So how to choose the client is to read some of their basic documentation here maybe, but also it's up to you, like whether you want to uh, invest your time in a specific language and specific code base. For example, you are a Java developer, so you might be more comfortable with Besu because you understand its approach more, etc. So the language is one thing. Another part is the client diversity. This is more important if you are running the mainnet node long term, or or using running validator, but um, but we won't really care about this, and we will actually default to the get, which is the majority here. I decided to use as for a default get for two reasons. First, like it's most used for a reason, because it's easy to use, it works well, there won't be any surprises, and a part of this, like the easy configuration, also has pretty good logs, like it really explains well what it's actually doing, and we can learn from it. And we can, of course, if we have extra time, we will swap it for another client player. um, yeah, the combination doesn't have to be in the same. It's the same thing implemented in different languages. That may cause troubles if you don't have a proper testing. But as the week 4 explained us, we have a pretty robust testing which ensures all the different clients should talk to each other. And does it work on ARM? Of course, it runs on ARM. The different clients provide binaries for different architectures, but also you can compile it yourself on an ARM machine, or even RISC-V. But yeah, so yeah, first thing, choosing the client pair. So I would advise you folks, you can completely go with the Get and Lighthouse that I will, but you can just choose any other client. I would do a little challenge. Like I'm not sure how many people are here in the stream right now, but if we have at least like 20 people, we should be able to run like every client combination maybe. So it would be pretty cool if you want to try different combos. Like feel free to write down in the chat like what combination are you going to try. And if when you choose a client, you head to its documentation. So learning about here, I had some examples. Here with best Oregon, right? So you can read about, to open the Get and Lighthouse documentation. In our case, this goes to releases. We go to docs here. And before running the mainnet node, before investing to hardware and so on, I really recommend studying the docs. In case of Lighthouse, they have this Lighthouse book. Let's see how easy it is to find the docs from their GitHub. Is it this one? No, it's not docs. These are not docs. It's the Lighthouse book. I wonder where is the link. Here, Lighthouse book. Yeah. So we open the docs and we will follow this. And yeah, so we choose the clients. We make ourselves familiar with what is going to about to happen. And yeah, we have Besu and Tickle Java setup. That's awesome. Red Lighthouse on mainnet. That's pretty cool. Okay, we have 3 combinations already. And yeah, and the environment. This is another important thing. So many people were asking about like hardware requirements and so on. For this workshop, I want to keep the hardware requirements as minimal as possible. This is what you are looking at right now is a KVM, a virtual machine. Yeah, in oh, I don't even have an HDOT. I just spin it today for purpose of this workshop uh, to uh, to demonstrate how to do it on a fresh system. So we have like, yeah, 3 CPU cores. I've allocated 6 GB memory. It will be very small instance. And if you, I mean, of course, this is also doing some graphical interface, minimal graphical interface, but you can do this on a virtual server. You can just rent a small VPS for like $4 a month, and that's enough to run a ephemery node, for example, or just try it yourself. So regarding the environment, we are using Debian Linux here. It works on any Linux distro. It works on Windows. It works on Mac OS. Mac will be similar to what I'm doing here. The Windows steps might be much more different, but again, you go to the docs, and we start with introduction, installing get, and here you see the first goes macOS even before Linux. Here is Ubuntu, Windows. So you follow the instruction specific to your system here. I will be demonstrating those for Debian-based distros. So yeah, I think we can get into it by obtaining clients. How to for installation as this is a fresh install, but I already installed some basic things. You see I was missing htop, but yeah, curl, git, gpg. I wonder if I have all of that. So in Debian based distro, you can you use your package manager ideally. For some compilers which might be outdated in your package manager, especially on Debian, I have a bunch of outdated packages on Debian. You want to go straight to the website and download it with, like, I don't know, Golang. You can just download the binary. There's Rastup for Rust and so on. I didn't install Docker either. Yeah. So let's see if I have the GPG. I think I have. Yeah, it's already installed. Okay, cool. Because we will need that just in a second. Let me turn the camera here. Maybe, yeah, Josh, can you make me, like, can you make full screen so we don't lose a piece of screen there. But yeah, and let me know if the mic is okay. Let me know if you can hear me well, because there's a lot of typing and so on. So I can switch to the phone mic in case it's bothering you too much. Yeah. Yeah, just won't disappear. Did I lose the mic? I was just trying to remove the little square there. It's okay. Yeah. Oh no, that is perfect. Okay, awesome. Yeah, I just wanted to have a bit more space in the stream. Yeah, let's go into it. So let's obtain. Yeah, if it gets too much, let me know. I will try the different thing. But let's start with the obtaining client. So the most basic way how to obtain the client is to download its compiled binary. So this is like already finished piece of software you can just run, right? We can download it and execute it. So these executables are in the download pages. We saw the one for Lighthouse in the releases. Let's head to installation, and for the get, we saw it here, right? So let's start with get, and yeah, we choose the platform, right? And we obtain the binary. But what I'm doing here is I'm downloading already finished piece of software from already from that I'm basically have to trust, right? This is something that was compiled by someone else. I cannot, look into it, make sure that it's according to the code, because I didn't compile it myself. We can demonstrate the compilation later, but I don't want to waste time on it right now. But what we can do is to verify the signature of the of the binary. So get signs. We can also should check some here. Get signs their binaries with PGP with keys which are listed in the bottom here. You see, we can import them here or download them directly. In our case, we want this Linux builder key. Yeah, okay, we have them here. So now let's import the key, and let's import a key, and yeah, I'm finally getting a new computer. It got released recently, and what was the name of the file? Yeah, remote key. GPG import. So now we are doing the public key cryptography that also Ethereum is based on, right? Oh wait, this is macOS Builder. Did I click on the Linux one or the macOS one? Yeah, this is the Linux builder. So now I use my local GNU PGP keychain to import a public key of this Ethereum Go Ethereum Linux builder, which is a key that signs the Linux binaries. And it's part of my keychain. I can now use it to verify this signature here. So we have so we have this one. This is the signature, which is a little bigger for you folks. This signature, which is verifiable against the public key. So let's do that simply by GPG verify, and now we can actually just pass the pub key, and it will find the the signature, and then it will find the binary. So you see we have a good signature from this builder. So so we can be sure. Yeah, added it to added to my keyring with the import. Yeah. So now we can be a bit more sure that nobody tampered with our binary, because especially if you are running some serious infrastructure, if you're running a validator, this is necessary to do. This is something that ensures the integrity of the file, because maybe this downloads get.ethereum org, maybe it got compromised, maybe there is a hacker serving malicious binaries trying to spy on you, steal from you, destroy Ethereum, whatnot. So you want to make sure you do this, or you compile it yourself. To compile, maybe I can do it quickly. Maybe I can do it very quickly while we set up Lighthouse. But yeah, I wanted to demonstrate it. If you are not aware of this important step. If we do something like this, starting with and to actually we can just make cat if we have there are different. This one interesting thing I can show you. If we are compiling get, you can actually get a bunch of different utilities. So here we want to just clone the repo, and second. And then I would avoid compiling Lighthouse. That's what I'm thinking about it, because like Rust compilation times are terrible. So maybe better compile get. It might be faster. And I hope my internet doesn't degrade too much now. It's downloading. Anyway, here in Lighthouse, let's head to the pre-built binaries as well. And here we have information on different releases. So let's go to the releases page and look into it. We don't want experimental 3 states release. This is a version of Lighthouse which changes the database architecture to 3 states, and it's just experiment right now. We want this is the latest stable release 5.10. We see the changes, the change log here. And it's actually important hotfix. So what we want to see is here. So here we have Here we have the binaries for the Lighthouse. So let's download it. Let's just still. This takes a while anyway. So let's also actually one thing. So if you are using a VPS, if you just have some remote rented server, or if you don't have GUI, you don't need to just click on this, but we can just get a link and download ourselves like this. Yeah, now it's downloading Lighthouse, but I'm going to kill it because this actually I don't like to. So I was using vget wget there, but what you can do is use curl for that, and you can enforce TLS v 1.3. So to make sure that it's actually end-to-end encrypted with the server you're downloading it from. So if you want to be fancy, you can you you can download it binaries like this. Yeah, and we have it right here in home. Yeah, not in downloads. Anyway, let's actually unpack it now. So we have both binaries now. This is still cloning the repo. Anyway, it's a huge repo. Let's untar it. Did you guys know that tar is from the tape archiver? So it's literally like from the tapes. Okay, yeah, and we have the .lighthouse here. Amazing. Let's get rid of this, and let's bring the or yeah, we have cat binary here, and this. And now we are here in home with both our binaries with Lighthouse and GET, right? So this is unpacked. Oh, I didn't check the Lighthouse before I didn't check the PGP key. I'm not sure if I should do that, but maybe let's show you because yeah, you guys, I see that you guys were yeah, it depends. There are some key servers which might give you troubles. Let's download it again. And it's funny, it's cloning so slow, but downloading, yeah. Let's use, yeah, this is the key. So to obtain the key, you need to get it from a key server. Maybe they also have it somewhere, but it's probably somewhere in a key server. So we want to do GPG, key server, keys, open pgp.org, maybe, search keys, and we pass the key. Yeah, Sigma Prime. Yeah, awesome. Let's do it. And now you want to import it. Yeah, okay, nice. We have it imported. We can list our keys to show you guys. We have all of them. So we have the Mac builder that we accidentally did, the Linux one that we used for get, and now we have the Sigma Prime. So now we can actually get the signature that I didn't verify before. Oh, did I do portable or yeah, portable, yeah. So the difference here, and you can maybe notice it in other software, in other clients, the difference here is that this is compiled with different Rust compiler targets, different configuration, and there are some systems, some architectures, like some maybe Debian virtual machine, which won't understand certain instructions compiled with the default most performance mode. So this is like, of course, if you want to achieve the best performance, which means like gain maybe smaller, like few percent of the performance, best to compile your client on your own machine. Hello to Gentoo users. Yeah, so we have the, oh, I now have it in downloads anyway. Yeah, let's get it from there. And now we can GPG verify this one. And we have a good signature from Sigma Prime, security at Sigma Prime. That's nice. Okay, so I believe that if the key server is not compromised and the GitHub is not compromised, we have a good client right here. So actually, let me remove all of this. Just want to clean and there it again. Get rid of this, and now we have the get and lighthouse. That's really nice, and we are ready to launch it basically. Yeah. Here is the repo done, so we can go to Go Ethereum in case you want to compile it. Yeah, all it takes is to make get. Oh, I don't have make. Okay, you need to install dependencies first. So you want to go to yeah, always your documentation. There is no docs on compile here. Windows, FreeBSD, Docker, both from source. Yeah, doesn't mention all the dependencies. Yeah, I don't have the make command anyway. But I believe I have Go. Yeah, so it's working. So yeah, this is how I would. It's still getting a bunch of other packages. But I just wanted to show you that like when I say make get, it's going to compile get as the utility get, which is one of the things that that this repository can do. It's like one binary which interacts with a bunch of other packages, and here you can see the different packages. So for example, we can have like a boot node to run dev peer-to-peer communicator clef for consensus. So to just give you an example, that I can do like not just make cat, but I can make all as the documentation suggests. If you want to do all the utilities, but let's just do let's do the peer-to-peer. Oh, not here. So let's go to the peer here. Oh, here. No. Okay, now. So yeah, you can go build each of the parts of GAT. So if you want to, like, for example, experiment just with the peer-to-peer stack, you go to this part and you compile just this, or you can just make this is what the crawler was based on, for example. So if you want to play with crawling nodes, you can just modify and compile this little utility and so on. So compiling the client gives you multiple benefits. First of all, you can just have those parts that you really want to use with exactly the same the compilation configuration that you want with the optimizations. So it might be running a bit faster in your software and on your hardware. But most importantly, I read the code, right? Here I can see exactly what is happening. I can see that I'm running the actual code that I read, and I compile it by myself. So yeah, again, if you trust the compiler, we have like a trustless setup here, where we can run Ethereum without anybody interfering as a free software. So yeah, that's what I wanted to explain with the compilation part. But for developers, for people who want to look into this, go ahead. But let's assume we have already compiled or downloaded or whatever binaries. Now we have raw binaries here. So of course, these are technical workshop. I'm not using any third party to run this. Like there are these dep nodes, Docker setups, and so on. And I would say that like for practical purposes, if you are actually going to run your node long term, it might be even better to use something like some of these because it comes with all the packages pre-configured, etc. But if you want to learn how it actually works, you need to look into the configuration by yourself. So that's what we are going to do now. We're going to look how you actually configure it manually, which again might cause some issues, some troubles, might be problematic for someone, and doesn't come like or automatic from some packager like these, but it gives you the full control and the insight, and of course your technical folks. So we will look into that. So yeah, we download, verify the binary, we compile the clients. Now let's run it on a testnet. So let's do it. Let's run get. Check it, I'm running get. Okay, it was easy. So yeah, basically just executing the binary here. to minimize the Firefox to better, so I can see better. Are there any questions? I have questions somewhere here. Here is my little Discord thingy. No, wait, I have. Okay. So just running Theco as a beacon node only without validator duties. I'm not sure exactly where did you read that in the documentation. What does it mean? But like we will get in there that like these consensus clients, they come either integrated or with extra package of the validator client. So there is the beacon node itself, which is connected to other beacon nodes. It's making the network, and the validators were doing all these validator duties. But now we start with execution part. We start with get, because like just like 2 years ago or less, this would be all you need to run Ethereum fully. So let's read the log. So let's before we configure it, let's actually look at the default configuration. So we can execute it. And it runs the default configuration, which is of course Ethereum mainnet with some default values. So we will first look into this and then how to configure, how to change it. So yeah, starting get on mainnet as default. Here is the cache that it uses for mainnet. Here is the peer count, so it's targeting maximum of 50 peers. Garbage collection, gas cap, 50 million. So this, yeah, this is setting the gas per node. Yeah, there are different KZG libraries you can choose. So this is using the Go implementation of KZG, which is needed for the 4844. What is the different? Yes, I'm sorry, I have to break it here, but there's a question about the different kinds of data availability. I think I missed the question before. So to answer you, there is basically two kinds of things. One is like full node, which can be achieved over snap sync or full sync. And there is archive node, which is full synced, but the difference is that a full node doesn't keep all the historical states. So if you want to, the state is the current moment in Ethereum, where this user has X amount of funds, this contract has these values in this database, and so on. So the current snapshot of all the values in Ethereum is kept only for the last last X amount of maybe 100 blocks or something in case of a reorg. But it prunes all the historical states because it's completely unnecessary. So the archival node keeps all these historical states, which is only for certain purposes. It's kind of useless, and it's big amount of data. So in the default setup, as here, this is by default get does snap sync full node. So you can see that here it's ancient. So like all the historical data, all the blockchain data, which is not the current state, but the blockchain, which we verify all the hashes to the current value to make sure that it's a chain of blocks. That's kept in the ancient database, which is like this few hundred gigabytes of all the historical data. So this is, we can write into it. You see it's not read only, allocate cache. And this is, one small interesting thing is that it's using Pebble, which is instead of LevelDB, because LevelDB is not maintained right now. So get switch to Pebble. Maybe you can configure this as well. Initializing the Ethereum protocol, writing default main Genesis block. This is important. So you see, we run get on mainnet by default. So it uses its in the get binary. It has hard coded values of the Genesis block. The Genesis block itself is written in the client, so it automatically knows what to start with, and it uses this hard coded defaulted main Genesis block to initialize the database. And here you see its values. So these are the configuration values coming from the Genesis, that it's chain ID 1, mainnet, right? This was added for like this is like every Ethereum network has a different chain ID. So there are L2s, there are testnets, especially with like higher values, and every fork of Ethereum, one of the millions you can see on CoinGecko, has like some different chain ID. This is important because with chain ID is part of what you are signing with a transaction, which means that it cannot be replayed on another chain. It's an important protection, which happens. So we see the current consensus is the proof of stake, depending on the beacon chain, merged from ethash proof of work. And here are the pre-merge, the original hard forks, and their height. We see when the Homestead DAO fork, all these pushes of Fort Bomb happen, Byzantium, Berlin. You see the block heights. So the client knows that at this block height, this sort of rules apply, right? And then there is the moment of the merge. Network is known to be merged. It's already known in case like you have some older version of client, you might still be able to sync it, but it will figure out that it's merged later. And this is the difficulty of the network, at which point the network merges and post-merge. So yeah, you see all the fork data here. Yeah, the most recent block is number 0, of course, because we didn't have anything in the database. And then it doesn't have any snapshot. It's trying to build the first snapshot, and as you see, it enabled SnapSync. So by default, it's running on SnapSync. The SnapSync works in a way that it downloads a snapshot from the network of like relatively recent state. So like some finalized blocks before they alter something, and then it starts building from this moment. If we change it to full sync, it still then downloads all the historical data, right? And verifies everything. But it's more practical and much faster way how to do it. Is a snapshot. It's a different representation of the database. So like the get database, the state database, the Pebble or level DB is the Merkle Patricia tree Pebble thing. Level DB thing, which is very different to the snapshot, which is like basically just a database of the accounts and values, not a tree. So it needs to generate the snapshot. Somebody like clients in the network generate these snapshots. The other clients fetch them and then build based on them. And we see that it needs the beacon client to sync over the engine API. This is our peer-to-peer is there. Here is our as it connects to the peer-to-peer network, it gives us the public key, the identity of this node. It generates some default. Nice. The IPC is communication endpoint, very fast. JWT is the authentication we will need for the beacon. We will set it all up. Oh, it also runs this another endpoint. It runs this HTTP server is for connecting. You see, it has enabled authentication because it's connecting to the beacon node, or this is where. And then when I killed it, when I send the interrupt, Control C, it's writing down and shutting down all the endpoints. So this is like a simple run of get. I wanted to show you what happens when it starts. So before we configure it, before we run into something more. So let's maybe put in the screen. Oh, I don't have screen. Yeah, fuck that. Okay, we don't need screen. Let's just start get. So now based on this, you saw the default values, you see how it behaves, and now we want to configure it ourselves, make sure it behaves the way we want. As you can see, there was the default data store is .ethereum in your home folder, which is not ideal for me. I want to have it in some more obvious way, and I want to run different networks. So we are going to make also a different get data. Let's also make lighthouse data. Let me see the questions quickly. Comprehension. So if I run a full node and I want to grab all for SDI or something, what happens? So you can see all the current data. You can see how much your account or SDI or any other token what they have in database right now. But if you want to know it at a block 1,000,04873 somewhere sitting 5 years ago, you need to calculate it from the blockchain data you have, and it's a lot of calculation. So you need the archive of these states for that. So unless you want to calculate all the states based on the state transitions from every transactions that you have in the blockchain data, you just cache the created state, you just keep it. And that's like kind of naive approach. Actually, it's more complex in red and Aragon. They have this different database where they keep like the state changes, and it's much more complex, like 2-3 terabytes now, and you can have that, but you don't really need it. Like nobody really needs. I'm running it because I like it, but no normal users need this to interact with the network or to fully verify the chain. Right, but full node doesn't have all the full node has all the blocks, has all this ancient data. So when I go to, we already opened chain data. Here we have all the data. It's of course in this level DB Pebble format, which we cannot just read, but it's all in here. So you don't really you have all you can check it exactly in the client documentation. I don't want to lie, but like transaction receipts, the transaction info, the blocks, since Genesis still now is part of full node. The big, like for example, what you're talking about is basically for force. In the last talk from Dom, he mentioned it as a part of purge, the history expiry. The EIP 444 talks about like just not requiring this ancient or this like historical data to be part of nodes, which would make it easier to run. Because you don't really need it. You need the current state, but yes, to verify everything, you keep all this data in Genesis. But in archive node, you have these extra calculated states. Like that's the difference. I want to emphasize the difference between the archive and if you want to, basically like you can, so from a full node, you can be fully offline. You can have a full node and you generate the archive node data from it, right? You have all the data you need. You just need to do all the ridiculous calculation, which is just too much to do it every time you want to do a query for some historical data. So then you cache everything and you have an archive node. So yeah. Okay, let's get back to this. We made a data there. That's the first thing I want to configure. We have the get data. So let's use that. So first thing it's data dir get data. So first we point get to store its data in this directory. So if you are, for example, running the bigger node, if you need like terabyte of storage, you might have like external SSD, you might have like some external drive where you want to do this. So then you would point get to something like that, like media SSD, whatever. But in our case, we just want a local, a different local database. We can like differentiate between networks, etc. Okay. Then we can. So yeah, the sync mode, the default is the snap. This is the default. We can change it to full if we want. If we want to start from the Genesis, but let's keep it a snap. Basically, even if it's default. This is not a minimal configuration, by the way. I'm showing you some more options that come into my mind, but if you want to see like the minimum viable get config, you want to come here, run a node here. So what do we need to do? I didn't specify it, but the network is mainnet. Actually, I should have show you help first. Yeah, let's show you help. So here you see all the options. It's kind of overwhelming. I don't want to go through all of it. Just because it's kind of, you can read. So yeah, one important thing, there are commands. So I just executed get as the get node, but these are all the different commands, all the different utilities that you saw for using get via console, manipulating database, etc., etc. So yeah, here you can see that. This is for if you have an account within get, you can use this. These are some old ones. API. So yeah, we want to set up the authenticated endpoint, and we also want to set up the normal HTTP, which is false, which is closed by default. So we want to be able to talk to our nodes over the classic JSON RPC, which is this one. And yeah, the default is 8. We can maybe leave it at that. Yeah, more, and also you can enable WebSockets for different kind of communications. Yeah, here is the, you can have all this config in one file. Of course, you can point to that. Here is the Pebble or level DB option that I explained, data there, and you can split the HNs, the historical data, to see different directories. So for example, you have like a slower, bigger disk with this, and faster with the later data. Oh, and this is how we choose the network. So we just pass it the network name. These are the pre-configured networks, right? Mainnet, Holoshki, and Sepolia somewhere here. Yeah, Sepolia. However, Get or any of these clients, they can run on any compatible network. We just need to supply the genesis and the nodes to connect to, and it's able to run on another testnet or so on. We'll demonstrate that soon. Yeah, security concerns when I'm enabling HTTP API. This is a great question, and we will look into it. And let's look at the options. So yeah, so first of all, like you are able to talk to your node. You use different namespaces. Based on that, we can see it in the documentation here, interacting with GET. So you see these are different namespaces which GET enables, and the one that like kind of comes as potential dangerous is admin, because this one actually lets you manipulate your node, like add peers, remove peers. The first thing I see here. This one manipulates with the node itself, but also debug can be dangerous, because there was a question here about like the archival nodes. But for example, if you run like a debug ask about some big piece of data from historical moment, you can like DDoS the node. You can really like halt it, because it's going to try to calculate it. So there are different namespaces. But by default, you see it's exposed only in the local host. So if you trust your local machine or your local network, this should be all right. You can handle with firewall and so on. But what you can also do is to decide which namespaces you want to use. And I'm trying to find the comment here. Which lets you out RPC GraphQL HTTP address. Yeah, API. Oh, this one. I'm blind. Yeah. So HTTP.API lets you choose only which of these namespaces you want to run. So, for example, you only want to run EAT to only give you the basic information about the Ethereum chain. So you can just choose that. We can do that as well. So this can add like a bit security as well. So yeah, thanks for the question. So yeah, and it's most likely can be a DDoS problem. So yeah, make sure you run it on a machine that you don't want to have DDoS. It's locally safe and so on. Yeah. If you want to run archive mode, this is where you enable it. You need to basically disable the garbage collection, and you can run you can just retain all the history. But there are more. It's just state history, but for example, cache pre-images as well. You see, you can like cache bunch of things, which is deleted by default, and mostly the node doesn't need it because it's trying to be as lightweight as possible. But okay, to run it with some reasonable values. So we already we've already started on that here. So let's continue. We want to run, and this time let's run on Holoshki. So let's add it and put it to the front. Holoshki, and yeah, we want to enable the HTTP, so let's enable that. We can choose the port or the address. Yeah, the default is 858545. I'm just demonstrating, and there are the various other things, like again, like for the security purposes, what you can do is I could have showed it here, maybe better than typing it. I'm sorry, I'm a bit all over the place. So yeah, you want to choose what hosts are authenticated to connect to you, which host name is authenticated to talk to the RPC. So this is something that can also add a bit of security, but also can give you trouble if you're like remotely accessing your own node and you have troubles. Yeah, you can use this wildcard, but be safe with that. Yeah. So that's another thing we want to do. So this is like the JSON RPC, but now there is the RPC which you actually need to be able to talk to the consensus client, which is the JWT authenticated endpoint, and that's out RPC dot or I mean it's enabled .jwt secret. So this one is going to let us point it to a place where the value should be. So let me explain this. So to communicate between the execution and consensus client, which is crucial, it's basically like within the software. It's like one piece of Ethereum talking to another, right? It's like, if you split get to two binaries or something, they need to have a safe way to communicate, and we do it with this Java Web Token. It's basically just a random 32-bit hex, just a big number, which they need to both clients need to know them to be able to talk. So so we create it either with the open manually, but we don't need to do that. We just tell him that, let's put it to /dem/jwt. Yeah, and yeah, I think that's basically it. These are like the basic things you want to configure. If you're running the node, like you want to know where your data is, you want to know where your HTTP communication is running, and the default, the outer PC, the port, the default is 8551. I'm going to keep it like that just to demonstrate. So yeah, this should be it. Let's see if it complains. No, it's running. So now you see that it's running on 17000, which is the postcode of Prague 7, Holešovice, and it's all of these hard forks and the merge happen at the moment 0 in the Genesis, right? So it's already done. And then the Shanghai happens that Cancun activates at one point. Okay, it's already found 2 peers and it's running. But as you can see, it's the post-merge network. So the beacon, the consensus is beacon, but there is no beacon client seen. So we need to launch one. That's our next challenge. Let's keep the window with get in here, and let's grab another terminal and let's move to Lighthouse. So yeah, again, we have the Lighthouse documentation here. We got the client and we see, yeah. So we get a JWT secret. It was created in the temp. Yeah, it's here. You can read it, right? This is the value, the very secret value. Please don't compromise my node. But yeah, it's just communicating within the VM in a local host, so it should be okay. So we have that, we have the execution node, and now we want to well, we don't want to do staking, but we want to run the node. So yeah, here, or the very similar example should be somewhere here. Yeah, I think like there are these basic examples on Ethereum org, but I wrote this around the merge, and since then, maybe some flags are deprecated or renamed or something. So like better follow the documentation. And here you can see that it's also asking us for a checkpoint sync, and we will do it, but we'll do it in a moment. Let's start with just the default. So let's run Lighthouse. We have it here. You can see it's also many options it gives us, and they are mostly pretty similar to Get, but also very different in the beacon part. But the basic configuration is similar. We need to choose the network, the data tier, and connect it to the API. So let's do that. So we want to Lighthouse. So there are these different commands, you see. Account manager, beacon node, validator client. So basically, VN is the beacon node, VC is the validator client. These are two different features, two different behaviors, two different modes, or basically pieces of like code path within this Lighthouse binary, which lets us to either run the beacon node or run a validator client, which connects to a beacon node. So if we are going to stake, this is something we need to do later, but first we need to set up the beacon node. So let's start with that. We want network Polish key. The execution endpoint is actually the one that it says here. Yeah, we can pretty much yeah. The one thing to be careful with, if like some clients do, some don't like require the protocol here. What happens to me, I just forget, like, okay, Lighthouse wants the HTTP part there, right? And like in Get, you don't need it, for example. So that's something that oh, why is it not working? So yeah, and the execution JWT token was in /temp/JWT. Okay, and we also enable the HTTP endpoint, and we are basically ready. So now we are running Lighthouse. So what is happening now? This is a funny thing that I wanted to show you, because as I show you before, like the Get, it has the hard-coded Genesis file, and it writes it down and everything. In case of Holishkey and Lighthouse, it's a kind of funny thing, because a Holishkey network launched with like a huge amount of validators, and if you have all of these funded validators, this big value, it's a lot of space to take. It's a lot of, like, it's 1.5 million validators, so it's like whatever, at least 1.5 million records of this. That's like a huge amount of data. So the deposit sorry with the Genesis, in case of beacon node, it's like the configuration values in some JSON format and the actual state in SSZ format. It's so big, it's like 100 something megabytes. So they decided that instead of putting another 100 megabyte file as a part of their binary, they are just going to hard code this AWS address where you get the so this may take time on testnets with large validator counts. This is meant for Holishkey. So on mainnet, this shouldn't happen. If I go network mainnet, he's not going to tell me starting from known Genesis. Okay, here he is downloading the Genesis state, and then we fail syncing from Genesis insecure and coupled with data availability checks. You shouldn't perform a checkpoint sync. Oh, really? That's interesting. Why is it insecure Genesis sync? Oh, I mean, so I understand why it's insecure to download a Genesis from like this random server right here, but I'm surprised it does the same on mainnet, and it forces me to checkpoint sync, because in checkpoint sync you then trust the checkpoint sync providers. But let me show you. So what we can do on with the post merge network, with the beacon beacon nodes finalizing, is that if there is some block finalized, like some time ago, like hours or days ago, it's probably not going to be. It's not probably going to be just uh, 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 what's the word reorged so easily. I don't assume that, like, the history like few days ago will change, because it would require like a major slushing incident of billions and billions of dollars. So I consider this finalized moment in the history of the chain as what's this as like as safe as, or maybe even safer as Genesis, because I don't want to trust some random Genesis I'm downloading it from the server, but instead we trust these endpoints. So there are different providers, as you can see, and what we do is that um, we connect to their nodes. Here, this is using beautiful checkpoint software, and you see what epoch is finalized, and therefore we can. It has it's known. You can check this data, the state through the block root, with other nodes to make sure it's safe. And it's serving this checkpoint here, this 20-minute old finalized block as our kind of genesis, that like we start from here. So yeah, so it's kind of subjective, like so we called it weak subjectivity checkpoints, and it should be covered in the week 3. You can look into that. You can look more into the weak subjectivity. Like there is a good part on this in somewhere here. Consensus, proof of stake, with subjectivity. Uh, the you can read about this here. So this is about the subjectivity checkpoints. So we are going to use this website, and they are, thanks to each staker, we're going to download their, let's just randomly choosing one. If you do this on mainnet, you should check it between different nodes and different operators to have like more security. But in our case, let's just grab one. We are on testnet, and we are actually running out of time. I'm taking too long. Oh my god. Yeah, and now it's checkpoint syncing Holoshki, which might take a minute, but meanwhile, we can also execute get again, and we'll see what happens. Okay, downloading the Genesis state, and get is I don't have like in this VM, I don't have like the pinning to sides. I just want to show you the Windows side to side. This is terrible. Anyway, okay, get is looking for peers, and Lighthouse already loaded the checkpoint, which is really nice. So let's see if my computer will manage. And it's not logging new things, which is okay, something's happening. I'm not sure if my machine can handle this. Wait. Top. What are we doing? Let's do it on CPU anyway. Yeah, it should wake up any moment. Execution point. You see, they are successfully connected over the 8551 port endpoint. They successfully authenticated because it loaded the latest timestamp of the block there, and yeah, it cannot update the deposit contract info because this is not synced. So they are kind of waiting on each other. Get wants to find more peers for sure. Wait, let me maybe. Oh, what's the peer count? Max peers, right? Yeah, I have to remember max peers, so it's 3 or something small. So maybe it starts syncing sooner. It doesn't wait to gather more peers. Just want to show you more what happens when you start syncing. Yeah. Yeah, and my machine is kind of slow, so that's one thing. But let's look at our outline for the workshop to see how are we doing. So I could just kill a bunch of these tabs to get some, yeah. Okay, something's happening. Okay, we are running on ephemery. I wanted to demonstrate running on ephemery because this needs to be done using the custom genesis, and it gives you even more insight into like what the clients are actually doing. And actually it might sync faster because this doesn't look good. Although, like you see, they are successfully connected. They just need to wait a moment to wake up to connect to the network, etc. Yeah, to download ephemery to run ephemery, let's go to ephemery.dev. Yeah, I'm just gonna kill it now. Oh, sorry, not enough resources for all of you. Yeah, let's go to the project repository and the Genesis repository. So here is like a general information about a testnet and including, like it's restarting every week. So it's very small. It's like week worth of mostly empty chain data. So it can be synced very fast and very, very easily. And here's an example how to get the node working. You see, it's very simple. It's just an extra command. So let's start with that. We need to first download the latest release, which I was opening here, but let's go straight to releases. So you see the 119 with this chain ID, this Genesis time. Let's download testnet all, which is all the testnet data we can have. Okay, let's untar them. So just downloads, and it's this not all. And here we have, I just unplugged it right here. Doesn't matter, it's a mess. So here you see all the different. This is the ephemery genesis data. All you need to run ephemery basically. So to read this, to see what's happening here, the basic is the genesis JSON, which defines the actual network. So here it gives balances to different accounts, like for initial users, for testers, for validator, for faucets. Yeah, yeah. The difficulty, no extra data. Timestamp of the genesis is important when the network actually starts. And to get on the top, you can also see the forks, all these accounts. Yeah, so here are the forks, which are all happening at 0. Only the Shanghai and Cancun are later. Yeah. Yep. So this is basically the definition of a network. But then there is also more stuff you need to pick with this to be able to run it, like information about boot nodes. Which one is it? Boot nodes, XD. So these are the execution layer boot nodes, right? Genesis validator root, and the beacon state in this Genesis SSZ, which Lighthouse was downloading there. So we have it all downloaded here, and we can point our clients to it. So to use get with this, I was running get here on the Holish key, and this time let's point it to this testnet. And how we do it is that we need to let's make a directory with ephemery. So first we need to initialize the genesis. So we need get to write down this genesis in its database. Oh yeah, in here it's just an example. Yeah, it should be fixed. There's an example with like the old release, but just go to the release page and use the latest one. I should fix that because it's a bad example, but I understand it's confusing. So we want to initialize the Genesis. We do it with get init, but first we point it to the data deer. So let's use the data deer ephemery here. And we want to init downloads Genesis.json that I was showing you a moment ago. And now get creates the Genesis state in this database. So now in ephemery, we see that get initialized its data there. So it's basically ready to run. The next thing, also all the variables, all the values like iteration number or chain ID, boot nodes, blah blah blah, are in this values. So which in this document. So what you can easily do is source your shell to have these values. Right now we know them. So now you have it loaded in your shell, so you can easily run these commands. Let's do again get with data deer of ephemery where we put it before. DC secret at what do I need to do? JWT, and we need to tell them boot nodes, which is boot node enode, and I also want to add the chain ID just to be sure we have the right one. Okay, and it doesn't work. Oh, because chain ID is not defined. How do I? Oh, it's not chain. It's network ID or something. Network ID, right? Okay, my fault. Network ID. Okay, and now it's running. So now we are running on this custom Genesis that we created and downloaded. It's the ephemery testnet. You see, we are trying to, we already found 2 peers on ephemery. That's great. Okay. Now, meanwhile, in the Lighthouse land, let's do the same for Lighthouse. Lighthouse has this beautiful dash testnet, so we can do again Lighthouse beacon node, and it has this flag for testnet, or you can shorten it to -t, which just which lets me to point it to a directory with all of these. Well, I don't need to specify like, oh, here is the Genesis, here is the Genesis state, here is the boot nodes, etc. It finds everything in a directory like this. So that's very, very, very easy. And yeah, and the rest is the same. I'm just going to copy it. Okay, we have something's happening for sure, and it's syncing. Okay, this took a while on Holeshki. Now it's happening faster, so I'm glad I could show you. So yeah, again, it's get was looking for some peers. It found some that it can get the data from, and the same happened for Lighthouse that connected and wants to sync. And now it's syncing in a way that you see it can sync in a few minutes. It's amazing. So it's super small and it's syncing so fast, and it find out what is the it syncs to the current or the new slot, and then the fork choice dictates to get, oh, this is the new head. Oh no, this is the new head. This is the new head. This is the new head. Right? It always syncs to the next block and dictates to the get where to sync from, and it's also reading the data from the execution. So yeah, this can take a second, I guess, but it's eventually going to sync. Like it's running. Like this ephemery is very, very lightweight for yeah. So like Lodestar, for example, you can use the ephemery without this like downloading Genesis anything. It just runs because it's hard coded in there. The other clients did not include it yet. Okay, so we have 9 minutes. This is basically the longest it can take to sync ephemery. This is the worst time. because the network is restarting in like 1 or 2 hours. So it's like 1 week minus 1-2 hours worth of data. But if I do this in like 2 hours, it's going to sync in a second because it will be fresh network. So yeah, you can see here it's at here 1900 UTC. We started at 4, I think, right? So yeah. Okay, so that's that. So now if we have ephemery running, let's talk to the node. Oh, now I'm wondering if I enable the HTTP here. I didn't, right? Okay, let me do that. We want HTTP as well, so we can use it, because I want to show you how you actually communicate with the client. For that, the good start is JSON, or like also the client specific. Actually, the client documentation is pretty good, or the JSON RPC in the on the Ethereum org is also good docs, but get, let's do it like let's do it more client specific. Oh my god, this is syncing so slow. Oh, we can also like checkpoint sync ephemery. There is a checkpoint sync provider for ephemery, which would make it faster, I guess. Maybe we can do that. Is my quality, is it deteriorating when I'm running the node, by the way? Is it like dying or something? Because maybe it's worse when I'm syncing the node. But here, checkpoint sync, you see, we can use this website, which hopefully works. Yeah, that to checkpoint sync it. So what do we want to do here is, I just got this. Checkpoint sync URL, right here. Makes sense. Checkpoint sync URL. It's this one, and now it's going to comply. No, it's not going to comply. It works, but refusing to checkpoint sync because we need to purge DB first. You see, so if you already started the beacon node, then you cannot just skip to checkpoint sync because you need to delete the existing database first. So we are going to do that, and maybe it will be even faster. Let's try this. Yeah, and we have the HTTP for communication on 8545, and this one connected to Lighthouse. Okay, awesome. What I want to show you is the communication first over curl, simply CRL. With, yeah. Is there some examples here? Come on, there should be examples. Eat. Oh, eat. Yeah. Okay. So yeah, eat call. So just example of like eat call. Create access list. Nope. Okay, there are not good examples here. This is just the domain, the name specific. But yeah, here this is a good documentation with examples. So you can see all the different oh, come on, it's a bit slow to load. Yeah, we can just use this, and you can see all the different commands that you can run right here. But now we just want to do, yeah, let me just it's missing the headers. Actually, this is not fully correct, because what you want to do is yeah, for sure post, but you want to have header that it's content type communication/JSON, otherwise it might or probably won't answer. And now the what we are requesting here, the data. Let's copy that here. Okay, bit. Yeah. Sorry, I'm not used to the environment because it's just a fresh VM, and I want to go to localhost 8. Nope. Okay, and we see that the protocol version method is not supported, but it answered. That's great. It answered. I don't know why this is not supported. Which is funny, but we can ask about the syncing state, for example. It's syncing. Oh, it's not syncing. How is it? Is it synced already? Okay, it's synced. Okay, so while I was talking, it actually seems like it finally synced the head. Yeah. We see we are synced. Now it's getting just the historical blocks. The current state is achieved because we checkpoint synced, so now it goes backwards. The slide house. And you see, get here is happily importing every 12 seconds new blocks. So it's happening. We don't have many peers, maybe because I'm in the VM on like random internet, but yeah, it's chain head updated every 12 seconds, so it's following the current state. So it's not syncing. That was right. I was expecting it will tell me like, what is the current head and that it's syncing and so on, but it did not happen. Let's use some other eat. We can ask just like for block number, for example, right? So here I ask him the block number, and this is the current block number in hex. So you get these answers from the JSON RPC. With the values are mostly encoded in hexadecimal format. You can easily decode this, and it should correspond to the current ephemery head. So yeah, this is how you use the curl to talk to it. Of course, like this can be in so many different packages. You can have it as a Python package in Web3Py. In J, it's mostly used. This communication with this RPC is mostly used in this curl is good for maybe like bash scripts or something that you want to quickly check. But in reality, you use the Web3Py, you use something like ethers.js on the dApps, right? Or in the backend in Python or so on, or you use some already existing tooling, which makes it easier and wraps all these answers, so you don't need to like manually read all the fields and transpile it from different coding or something. Also, you can use this, of course, in your wallet. So let's maybe do that. I have a MetaMask here that I installed for this purpose of doing a workshop, and it has some default Ethereum mainnet whatnot, but we can switch to blah 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 blah. Yeah, I want to switch network, add network. So here I want to add network, which is going to point to my own oh wait, there's some questions. I'm sorry. Running best on Tech One Mac. Nice. Yeah, if you need help, we will get to that in the end. Yeah, add network manually. Memory in this case, new RPC. So we are doing HTTP localhost. This is where the it wants a chain ID. Oh, it could not fetch. That's funny. Is the RPC correct? Did it kill it or something? No. Maybe I need to allow like try a different RPC. So we test whether it's. That's not nice. So what you might want to do in this case is to kill get and look into the help for the HTTP, yeah, course domain. Yeah, so maybe we want to do the course domain or vhosts, just to make sure that this might be the problem. Okay, I'm wondering, but it should work. Like, I don't know, this always worked. Not fetch the chain ID. Localhost 8.5. What am I doing the mistake, guys? Come on, help me fix this. It's gotta work. Maybe I want to do instead. Five, maybe. No, it's the same. Too bad. Okay. Okay, what's your problem? Shut up. It won't work. This is weird. This is not nice. I can use it in my wallet. I'm very mad now. I don't know why this is happening. Oh my god. Guys, any tips? Any tips and tricks? Maybe we can try a different wallet, but it always worked like this in MetaMask. I wonder what's stopping me here. What was the chain ID? But it should fetch it by itself, right? Because you can just ask. And we just did it in the other window, right? That's weird. Let me try again. I want to show you 8 block number. Yeah, 8 block number works, and it's localhost 8545, which is also correct. So I don't know. 8 block number. Let's do the chain ID, which is correct. Okay, that's not nice, because I can reach it over curl, but I cannot reach it in MetaMask for some reason. Maybe there is something I'm missing. Maybe there's some browser settings or something. Yeah, it's idiotic to have a browser wallet anyway, but okay, I don't know. I'm so sorry, guys. I'm so disappointed right now. I'm not sure how to. Let's add ephemery here. Yeah. Let's add ephemery here. Yeah, this is disappointing. This is too bad. This is the public RPC, but why this doesn't work? It's terrifying. Yeah, maybe there is some extra config that I need, but I did this so many times, and I think that all I needed was just, this, and I actually have like my own node running, but with some, it's missing some headers, but no, it should work. It should work. I don't know. It's missing some stupid config, I think. Like, we have the course. Oh, sorry, this is Lighthouse. Yeah, we've been running it here. Yeah, maybe the course domain is wrong or something like that. Wait, can I do maybe can I do like something you shouldn't do, but just to try. HTTP dot. Oh my god, what is the address? All interfaces. No, some address. http.addr. Yeah, of course, it's addr. Okay, nice. Maybe now let's give it one more try, just because I'm getting nervous and curious, and I'm so sorry to disappoint you. I hope you'll learn something so fast. Yeah. Oh, this is good. Yeah, the course versions needs to be from the Chrome extension. Oh, that's so ugly. But let's try it. Let's try it. Okay, let's add a custom network again. And yeah, now I want Moz extension, which is this one. So should I just use this in the course domains? Okay, let's try it. Let's try again. Or maybe there I can. Now it's working. Okay. So okay, I did a wild card. That's probably like worst idea. Yeah, and it's currently in. It won't let me connect because it's currently in use because I already added the network before. Okay, now it works. It calmed me down, but yeah, this calms me down. But yeah, what I had to do, as you can see, is like to enable to put the wild card. Yeah, what I did is instead of specifying the Moz extensions, whatnot, I did wildcard for the course domain, which you shouldn't do, guys. Wildcard for the hosts, and also I'm running on all interfaces. Instead of local hosts, it's running on all available interfaces, including the local host, of course. But this is something you shouldn't do. I'm doing this because it's in a VM, and I don't mind. But you shouldn't do this in a, serious setup. Yeah, maybe let's change it to localhost just by killing this. And I wonder if the course domains themselves will help. That's an interesting piece of knowledge for sure. Add network again manually. This, I swear, this used to be better. Yeah, it works. So it's the course domains that I set to the wildcard. So yeah, thank you so much, Maldsden. It was exactly what you said with the Besu. It was the course domain issue. So it like that's a security feature that it doesn't let you to connect to your node from some random interfaces or something like that. There is something more that I wanted to show you with ephemery, and that's like running also the validator part. Let's see the workshop. Okay, we can maybe access. We did this. Oh, maybe also the console. So there is one thing on get you can do, and it's get attach. You need to have data here plus ephemery, right? And now we are in the console. So instead of using curl, I can just talk to him directly, right? Like, oh, tell me your peers. Here are all the peers I'm connected to, etc. So this is one little thing I wanted to show you as well. This might be practical, like for example, connect your node. So what you can do is go to ethernets.io, and here you see a bunch of different nodes. You can even check ephemery nodes, the current iteration, and here in help you find the these are all the instances of the peer-to-peer client that it's running. So you can choose one of these and add it as a peer, you see? So I'm going to connect. Now I added a peer of this enode. I just added a node to connect to. It adds it to a QE, and at one point, get will try connect to it, and that will help to maybe discover more peers and whatnot. And then when I go to stats here and I look at it, or when I go to the nodes part, and you can see the latest nodes, and okay, this is by node. You can see all the information about it, whatnot. So if you then connect to the scroller, you can read all these values by yourself. It's nice way to make sure that you see that yeah, so in this case, the crawler was dialing this node instead of the other way. So you can make, for example, make sure that like the dialing to your node is okay, etc. So that's something you can do after. But yeah, one thing how to add peers is like using the console, because what you want to do is like, don't have this is using the IPC. This is using as it said before, this is using this IPC file as a communication with node. So what you can have is like only engine, eat, net, takes, pool, web3, just like these safe namespaces enabled on your normal node, and then through IPC you can also connect to admin and yeah, handle your node. So that's an example of this. Well, I mean, you don't have to trust because you can verify their data. So these are not nodes. What I was showing is just like instance of the crawler. Is just to so they can gather your data more easily. So now let's do a little poll. What do you feel like, switching a client, or we can maybe go to the validator? That's like we are over 90 minutes now, and the validator was one last thing I wanted to show you. I'm not sure if I can, but let's look into it. Like, it's easiest on a film. Let's do it quickly. Let's go to Launchpad. Let's go to here, and let's go to faucet. Okay, first let's get some money from the faucet. That's easy. I don't need to teach you that. If this thing loads. Okay, the address here. Thank you. We have it. And if we want to become validator, we need to learn all the important things. Yeah. Don't do this, read it, especially if you are using mainnet. But now I just want to show you how to do the deposit. And this is actually also a good knowledge source, like the staking launchpad gives you some nice information about the different clients, about all the responsibilities as a validator and the configuration. I'm going to like kind of skip this because we know all of that. And here it tells you how to generate the keys. So yeah, this is something I want to show you. So the way that Ethereum validator works is that it's using some sort of private key to sign the attestation data or publish the new block. You need to sign this with your key. You deposit 32 ETH to the deposit contract. The deposit contract is the richest one on Ethereum, right? And you deposit your transaction in there, which then activates your validator. So you see that this is the deposit contract. You can read the code here, and you always make sure that you interact on mainnet with this contract. On ephemery or testnets, it's on different address, like 4242 something. If you are using Windows or something, you can use like a GUI like this, but we can simply generate keys using this. It's terminal. Come on, give me a terminal. Yeah. I downloaded the staking deposit CLI. So let's open it, and here we have this feature called deposit, and we can either have it with existing or new mnemonics. So you need to make a passphrase first. Let's do a new one, and this lets you generate the keys to import to your validator and then run the validator with it. Let's run one, for example, and we want ephemery in this case. This is important. We need password. Okay, sure. Okay, we need to write down. It's good to write this down, even on testnets. It happened to me. I was running validators on Holashkey, and I lost the mnemonic. I couldn't recover them, and I had to deposit again. It's annoying. So, yeah, you want to generate the keys, and now we have keys that we are ready to activate using using the deposit. Okay, so yeah, the deposit data. So the deposit data informs the website about the data or about our validated public keys that are going to the contract, and it's going to help us to make the transaction. So this is like it's like an easy way to walk through it, I guess. Okay, we have 32 ephemery testnets, one validator. I understand. It's good to doing it fast, but you can read through this to understand the staking much better. And let's make the deposit. What I want to show you is that how you then import the key. Oh wait, I have 32 ETH, but I need more because there are fees, right? Of course, there are fees. Where's the deposit again? Okay, one more time. I need the address again. Okay, this is actually a good point. I need to change this to 33 ETH or something. Okay, here we go. Okay, done. Try again. No, it still didn't mind the previous transaction. Hopefully. Okay. So this is mostly it. So we do the deposit now, just the deposit, and now the beacon here. You will see it in a second. That there is a new validator waiting for. So the problem is that now we have to wait and wait a second. So what I did, so it takes like hours to activate the validator on the network. Yeah, you see, it's in the QE. It was done 43 seconds ago, and it takes 16 to 20. So in the lifetime of this testnet, it won't happen because it's going to be inactive, and it's going to be pending till network dies. So we won't activate this, but I wanted to show you this. But still, I want to show you the follow-up now when we have those keys, and let's pretend we are waiting for the activation. So we go to Lighthouse, and this time we want to run the Validator client. Oh, but before that, we need to import the data. So we need to import the keys that we used. So let's do account manager, import from data dear. It's data Lighthouse here, or how do you call it? Yeah, LH data. Okay. With the testnet pointing to ephemery, which is sadly in the downloads. It's kind of a mess. And the directory puts us to the actual validator keys file. And it wasn't expected. Okay, I need to do validator import. Okay, now I put the password. So what you want to do if you have like thousands of validators, of course, is to create a file or just reuse the password. Like there is a feature for that if you're doing like big testing. But now we import it to the Lighthouse database. We have the validators here. So these are, you see, this is the public key, and we are now able to run the Lighthouse also. You can always just run the validator, but it's going to help anything. So now we need to run it as an actual validator client. So again, we want to use the T for downloads. We need the data here, which is LH data. And I think it could be it. I don't know. Wait, unable to connect to beacon node. Why I didn't enable the HTTP on beacon node? I did. Oh, I did. Okay, so of course the validator is connecting to the beacon node using the HTTP endpoint. So it needs to be enabled. And oh, you see here it's connected to the beacon node. This here it's connected to the beacon node, floating protection. Oh, we don't have, and it's awaiting activation. So you see it's going to take a while to activate, and we don't have free recipient. It's something that you want to always set up if you are running a validator. Do I have that? I don't have this in my, yeah, okay. So set up your address as a free recipient, and now we are successfully running the validator. I'm so sorry, I can show you that the stations, it's going to take a while for this to deposit. If I'm clever enough, I would do a deposit before the workshop, and I actually did this morning, but it still didn't activate. So yeah, this is the best I can do right now. Yeah, you see it's connected to the beacon node and it's just waiting. So now the validator client is sitting and waiting while the beacon node is checking, the get is checking, importing new logs, and finally the beacon node is complaining that it has only one peer. That's not nice. There should be more, but yeah, it's synced, and I'm going to kill it now because we don't need it anymore. But yeah, this was ephemery. This was the ephemery setup. Okay, also with validators. So yeah, we are at almost 2 hours. I think that's more than enough. And I don't see any questions in Discord. Oh, so no, it's not going to be activated in the next epoch. It's going to be activated like in many epochs, which is look into the the consensus specs, where it's explained well the activation period. Look for the activation period, which depends on how many validators are in the QE, and yeah, it depends. But for now, it's gonna be too long to wait for that. And I was checking the validators from the morning. It was like 8 hours ago, and it's also not active yet. I should have done it yesterday. I'm sorry. Mm. Yeah. Anyway, please let me know if you have any questions. If you have something else you would like to have me demonstrate. We discussed the environment and the clients. We get the clients through the binary and we compiled it. We didn't do Docker, but fuck Docker. We can do that. You can like write your own Docker script or just use the official. It's very easy. You just do Docker run. Well, like what is more problematic with the Docker setup is that you need to know how to like handle the ports and the networking, like whether you want to run it as a in the host mode, or you want to create a custom network, for example, when you are connecting to different clients from and it's best to have it in some compose file. So yeah, that's like some thing on the Docker. Using S, so custom Genesis, we did that. We didn't try different clients. We should try some other clients. I suggested Nimbus and Aragon for reasons that Nimbus is very lightweight, and I knew that it's going to be non-problem on my low hardware here. And also Aragon is interesting from the perspective the Aragon is interesting from the perspective of the way how it syncs, that like it has the stage sync, and you see it has interesting logs about like what is happening in this moment. So you can actually see this different paradigm of syncing, which is also used in red. Yeah. We accessed the RPC, we used validators, and I didn't get to like systemd setup, but maybe we can do it later. So now, if you feel like continuing, we can go to EPFSG workshop. This go like this. Okay, it's a bad link. Anyway, here we can meet here. If you want to continue, we'll come to this GT, and off recording, we can do some more exercises. If you have any troubles with your step, you can screen share, and I can ask you some you can ask me some questions. I can do some troubleshooting, but also if you have any other questions, like go ahead. The iterations of ephemery, that's 1 week right now. We're going to make it 1 month, but right now it's weekly from Thursday evening to Thursday evening. How to look the transaction mempool? So yeah, you're using the RPC as I was showing in the Ethereum or JSON RPC. This one is this is the best documentation if you want to see like all the different calls, and pretty well explained. So yeah, if you want to see blobs, you need to use the Beacon API, because those are on the oh, come on. Yep, this one. So for blobs, you can read like blob per slot in not events in no. Wait, why doesn't open? What's happening? Oh, okay, now. Oh my god. Okay, beacon, no, it's damn it. And which one is it? Pianos. Come on, there are blobs somewhere. Ah, here. Oh yeah. So based on the blog, you can get blob sidecars here. The blobs are not really interesting to user. You don't really have a need to get them unless you're doing like archiving of the layer 2 history or something. You don't need to access blobs. But what you might want to see is the transactions in mempool, which is, come on, it should be okay. It's not here. I'm sorry. I'm disappointed by this docs now. But this is just ETH namespace. Nah, the Web3 client version. Damn it. So you can get transaction by hash, but you don't have to do that. What you want to do is use the takes pool in here. That lets you look into. You see takes pool content is what you're looking for if you want to see the. Yeah, and of course the session is recorded. So this was recorded. Now I would shut it down and switch to Jitsi for more relaxed sessions. So if you have more things to ask or whatever, we can go to the Jitsi. So yeah, I guess that's the show. I think that's it, guys.
All right. Thanks so much, Mario, for this. And yeah, if you want to continue to participate and get some hands-on assistance from Mario, head on into the Jitsi. Thanks, everybody.
Yeah, thank you so much for making it through the whole 2 hours with me. I appreciate it, and I hope you learned something. Hope it wasn't too basic and gave you some useful skills. Maybe yeah. We'll chat more in Jitsi. See you guys. Thanks, Josh. Thanks, everyone.
Yep, bye-bye.